The next one is binomial theorem. So binomial theorem states that we have a plus b raised to power n is equal to nc naught a raised to power n into b raised to power 0 plus nc1 a raised to power n minus 1 into b plus so on plus ncn a raised to power 0 b raised to power n for every n belong to n. So we have to prove the result of this theorem. We will prove the result of this theorem by using principle of mathematical induction that we done in our first chapter. So we will prove the proof by principle of mathematical induction. So let P of n a plus b raised to power n is equal to nc naught a raised to power n plus nc1 a raised to power n minus 1 into b plus so on ncn b raised to power n for all n belongs to natural number. So for let n is equal to 1, P of 1 is a plus b raised to power 1, that is on the left hand side. Now on the right hand side 1c naught a raised to power 1 plus 1c1 a raised to power 1 minus 1 0 into b. So we get 1c naught is 1 by using Pascal triangle into a plus 1c1 is 1 by using Pascal triangle and a raised to power 0 is 1 and into b. So we get a plus b. So the result is true. For n is equal to 1. Now next step is inductive step, that is step 2. Let the result is true for n is equal to k, that is p of k. A plus b raised to power k is equal to kc naught a raised to power k plus kc1 a raised to power k minus 1 into b plus so on kck b raised to power k for k belongs to natural number. Now we have to prove the result is true for n is equal to k plus 1, that is a plus b raised to power k plus 1 is equal to n plus 1 c naught a raised to power k plus 1 plus n plus 1 c1 a raised to power that is n is here k plus 1 that is k plus 1 minus 1 into b plus so on k plus 1 c k plus 1 into b raised to power k plus 1 for all k plus 1 belongs to n. So as we learned in principle of mathematical induction, we will take left hand side to prove this result. So taking left hand side, we have a plus b raised to power k plus 1. So we will write it as a plus b into a plus b raised to power k. As the result is q for n is equal to 1 and n is equal to k. So we can use the result from the second part, that is result for Q for n is equal to k. So we replace here kc naught a raised to power k, that is kc1 a raised to power k minus 1 into b, plus so on kck b raised to power k. So we get here, first we multiply a, that is kc naught a raised to power k plus 1 plus kc1 a raised to power k minus 1 into a, that is a raised to power k into b, plus so on, plus kck a into bk, plus we have to multiply by b, that is kc naught a raised to power k into b, plus kc1 a raised to power k minus 1 into b here, plus so on kck b raised to power k plus 1. So if we see, that is we have, this is the individual term, this term is related with this, next is related with this, and this is related with second last of this term. So we will write it as, that is a plus b raised to power k plus 1 is equal to kc naught a raised to power k plus 1 plus in the bracket kc naught plus kc1, this outside a raised to power k into b, plus similarly kc1 plus kc2 a raised to power k minus 1 into b square, plus so on. In the last we will get kck b raised to power k plus 1. As we know that it may be kc naught or some index c naught, that is k plus 1 c naught or l c naught, all are 1. So we will replace kc naught by k plus 1 c naught. Also, we know that ncr plus ncr minus 1 is equal to n plus cr for every r lying between 1 and n. Therefore, also the third kck can be written as k plus 1 c k plus 1, which is equal to ncn, which is equal to 1. So using these three facts, we can write a plus b raised to power k plus 1 is equal to k plus 1 c naught a raised to power k plus 1 plus it becomes n plus 1, that is k plus 1 c r is 1, a raised to power k into b, plus so on k plus 1 c k plus 1 b raised to power k plus 1, which is equal to right hand side. Therefore, result is true. N is equal to k plus 1. Therefore, binomial theorem is true. All n belongs to n by principle of mathematical induction. Therefore, we can write a plus b raised to power n is nc naught a raised to power n plus nc1 a raised to power n minus 1 into b, the difference of these two terms, plus so on ncn a raised to power n minus n is 0 into b raised to power n, that is this coefficient. So this is the way to write the binomial theorem of any expression. So we get this is the binomial theorem for all n belongs to n, that is the natural number. So this was all about the proof of binomial theorem. Now in the next topic we will learn Crowley's result deduct from the binomial theorem by making some substitution by changing a, n and b, and we will get the different results that are called Crowley's.